Right, welcome everybody. Thank you so much for coming. This is our FPGA meetup for the 18th of February, 2025. And what we do during this meeting is we talk about what we have done and what we plan on doing. If we have any roadblocks in our way, if we need any resources. So to lead us off, I'm going to turn the floor over to Aaron.
Hello. Since last we spoke, I've been digging into the 809371. In OpenCPI, we have support for the EDIS N310, which has two daughter boards with the 9371. So my goal is to take some of that work and make it more generic so that it applies to other devices, other platforms other than the N310. Specifically, I'm targeting the ZC706 with the FMC card with the 9371. So it was basically taking an inventory of the device workers that currently exist that handle the JSD interfaces and getting the samples from the RF domain to the digital domain. So I did that with HDL the HDL workers as well as taking a look at the software is used. This is the OS library from analog device. So it's going to take some time to get it all working the way it should be, but the idea is that then that could be reproduced onto any other platform, including the Zinc Ultra scales as well. So that's what I've been working on. There are no blockers, and just give it an update.
Oh, thank you. I think we lost a little bit, just a tiny bit of the center part of what you were explaining. So you did a
Okay.
bit of a dropout in the communications, but I think that we got the overall gist and the arc of what you're working on.
I'm not sure exactly where I dropped off, but I apologize for that.
Oh no,
But it's,
totally not your fault. It
yeah,
happened, but
yeah.
I think it came through loud and clear. This is a huge amount of work, and yeah, the N310, we're more familiar, I think, around here with the X310. But
Mhm.
from what I recollect, the N310 is a network focused or a remotable version of like the 310, the X series. Is that accurate?
Uh, a little bit, yeah. The way the series goes, yeah, you're right that the N stands for network, and the X is experimental, I believe. But they have very big different architecture differences as far as with the transceiver. The X310 utilizes ADC and DAX directly, and then they implement their own front end and local oscillators. Where the N310 uses the analog devices 9371. So on the Pluto, it uses the 9361. So for the 9371, it's similar to the ADRV 9009 I think Ken is working on, where it utilizes the JSD interfaces and the multi-gigabit transceivers of the FPGA to get the samples from the transceiver onto the FPGA. So since they share the JSD interfaces, the work that I'm doing also might apply to that board as well. And this is for the high Faria and the bird side of what we're trying to do here.
Right.
Um, yeah.
Yeah, good point. Yeah. I think your instincts are right. I think we've found it can be a little bit fussy when you're assigning the channels,
Hmm.
but it boils down to digging through the documentation and figuring out exactly how things are allocated and what each individual implementation kind of wants in terms for like JESD 204B. Uh, so yeah, anything that can make that easier is a huge step forward and is a big deal. So, but it's hard.
Yeah.
Awesome. No, thank you so much. This is really, really cool. Is there any anything that you want to share, like a presentation or slides or images or anything this week or
I not this week. I attend these during my lunch break.
oh well thank
Yeah.
oh we really appreciate it. Time is actually very precious, so we really, really appreciate you. This learning what you're doing and being to help in any way is a big deal for us. So thank you very much
Uh,
for
oh
taking.
yeah, you're welcome. Yeah, one of these days, I do have some images that kind of break down how each of these interfaces talk to each other. And yeah, I can create a presentation to explain what I'm doing and what I'm seeing to share with you guys.
Cool. Yeah, that'd be welcome anytime that you can anytime that you're ready to share it with us. I think it'd be a enthusiastic and very positive audience.
Okay, thanks.
You bet. Paul, do you want to take the floor and tell us how things are going?
Sure. Um, this part of the story begins with the fact that we've been having trouble getting the signal transmitted by the one Pluto, which is received in loopback successfully, over to another Pluto, receiving it independently. And the leading theory was that the problem was probably frequency error between the two local oscillators, or or something related to timing generated by those. So we wanted to hook up the set the Plutos to exactly the same frequency to make sure that wasn't an issue, or prove that it was. And I found that in between my personal stash and Michelle's stuff and the stuff in the lab, we actually had two Rev C Plutos, and the Rev C Plutos have an internal connector for an external clock. So I brought those two external connectors out for so I can provide a clock, and I figured out how to set up the signal generator to generate an appropriate clock. And so I had built an entirely separate uh, Pluto to Pluto uh, test bench, so as not to disrupt the other work going on the existing one, using these two Rev C Pluto external clocks, and driven on exactly the same clock. And much to my dismay, the first test showed that it didn't solve the problem. We still had no success receiving on the independent receiver Pluto. Um, at that time, it retriggered my old suspicion that um, maybe that we were getting leakage on the loopback, and that the leakage was what was working, and not the RF loopback. That would open the possibility that maybe some different kind of handling of the RF would work for the independent receiver. So I decided to make sure I knew the answer to that question. And so day before yesterday, or whenever that was, I spent a good long while doing a systematic measurement across a range of signal attenuations, from nice and loud, which gives us a very consistent, perfect reception on the transmitting Pluto through RF loopback, all the way down to where it seemed to be at the very threshold of what we could reduce the signal to. And I've graphed and or captured and graphed the transactions from both transmitters and receivers, but mostly the transmit loopback was the thing of interest. And sure enough, as I dropped the signal power by 10 dB at a time, the performance got a little bit worse and a little bit worse and a little bit worse on the RF loopback. I'm able to receive or check the signal strength being received by loopback using the built-in RSSI received signal strength indicator uh, capability in the radio chip. And when I dropped it down from my nominal power, which is set by having a 10 dB attenuator on the output of the transmitter, which is the maximum level you can guarantee not to damage the receiver if you loop it directly back into the Pluto. Um, and then splitters, which each cost you 3 dB to um, to distribute the signal to the spectrum analyzer into both of the receive inputs. Um, and then by 10 dB down to 80 dB worse than that, using the little inline SMA attenuators. And as I got near the bottom of that, it stopped. The signal stopped getting smaller at the receiver, which I think just means it's been uh, kind of submerged in the noise and the leakage and the loopback and stuff like that. But looking at the graphs, you can see that it went from loud enough to be nearly perfect reception all the way down to the loops can barely capture it at all. You can see the accumulators pulling in with great difficulty at the lower signal strength on the loop back. So I think that justifies a strong conclusion that yes, the RF signal coming in the receive connector is in fact what we're receiving primarily on the loopback test, and there's no reason why that we know of why that signal shouldn't be receivable on the independent Pluto. And now we're back to the question of why doesn't it, and what exactly to try next. So that's my status right now uh, in the experiments. The remote lab status is, except for the addition of uh, that secondary Pluto to Pluto test setup, is pretty much status quo.
With some memory usage from training deep learning, where we
Yeah.
found out that we can actually crash the VM when we use all the
Use
memory.
up use up all the physical memory and all the virtual memory, then yes, it crashes.
Yeah, I should have known. But anyway, yeah, we figured that out. So a big step forward for knowing the limits of what we have. That's been good work. So thank you for helping with that as well. Cool. Okay. Anything else? Anything we need to be doing or any planned outages or anything like that?
There is a need for a planned outage, but I haven't planned one yet. So um, there's a new version of Unraid to upgrade to, and there's probably some other stuff that needs to get shuffled and tried. Um, but for now, no.
Okay, cool. Yeah, just let us know and we'll work it in. Okay. So I think let's let Matthew have the floor.
All right, thank you. Um, there's not much to report this week. I've not had much time to work on the MSK design. Looking forward, I think the main activities are just seeing if we can resolve or figure out what's happening with the independent receiver. Um, and I was Uh, last week, I had mentioned about putting together a UVM test bench for some of the blocks, and so that's still ongoing. Um, one thing, I don't think it should affect the receive capability, and I'm not sure. Yeah, it shouldn't have any effect on the receive capability, but I'm thinking we want to include a spectral inversion because Paul had noted that with the complex IQ outputs, we're seeing the one of the images canceled, and in this case, it's the upper image versus the lower image. And we didn't pick one or the other for any specific reason, but if we it can be useful to have the ability to select one or the other, especially say if we're near a band edge. We'd want to um, pick the one that's away from the bandage. So, um, so I think that would be another useful addition. So I've put that into the Trello card, tracking things that we want to do or add or need to do for the MSK project. Um, no other updates at this point that I can think of.
Okay, well, thank you so much. There's been a whole lot added into the repository. So lots of things moving forward and testing. And then just to kind of follow up on what Paul was talking about with trying to figure out um, what to do next. So I had proposed to him that we actually go ahead and try streaming. Um, what we're doing now is sort of a controlled, like uh, timer based release a bucket of bits. That's what we've been calling it. So release kind of the bucket of bits and then do lots of measurements. So one potential, I'm just trying to anticipate if there's a reason why we're having the sort of the troubles that we're having. If we go ahead and just try streaming the streaming examples, and this sort of the streaming framework from IIO and see what happens. And so I think I'll need Paul's help. We'll sit down and we'll work through the code. The application right now supports streaming. It supports streaming from the base example for the 9361, but we haven't touched it. It worked. We got it to work. That's kind of your hello world. The baseline streaming example only does a very minor modification to the data, and it uses DMA. So I think that we'll go ahead and try that. That's in parallel to like continuing to bang away and try to figure out how to get it to work.
So are we talking about streaming the IQ samples or the received data, the demodulated data?
Oh, that's a good question. I was talking about just going back to the IIO streaming, transmit and receive. So it's a transmit and receive streamed through DMA sort of example that we would have to
Right.
but it would be instead of what we're doing right now, we'd go back to the sort of the streaming framework and just see what happens to kind of see if uh if the actual structure of how we're ordering the radio around is getting in our way somehow. So I'd just like to eliminate any of the assumptions that we've made in setting up the radio and in trying to measure it, that maybe this instrumentation that we have or we're relying a lot on sleeping essentially and then waking up and then checking things, that maybe going back to streaming and see how it works now that we have all this logic in there, that maybe that'll reveal some more information.
Yeah, it was occurring to me that if we streamed the IQ samples before they're demodulated and detected on the receivers, we might be able to compare or correlate the two receivers and see if we're seeing some difference in the signals.
Oh, yeah, okay.
But between the loopback and the independent receiver,
Yeah.
just trying to figure out what's different, and so if we had the raw IQ samples, we could FFT them or do other analysis of them to see if we can find some difference that could account for the independent receiver not playing nicely.
And I'm not sure we have the bandwidth to stream the IQ directly out of the receivers, and we chose to sample at 61 megasamples per second.
Well, we could take the decimated ones, and we could just take the real as well. We don't have to take all the I and Q, and because we're only demodulating the I channel.
Yeah.
I mean, we might be able to get the rate down some.
Okay.
It might be more useful to take the decimated samples in anyway, right? Since that's what that's what the loops are locking to and what we're trying to demodulate.
Okay. Yeah, I think we'll work on this week and try to come up with an experiment that kind of leverages what we've had in the code, and then try to make some progress and report it on Slack. But
Yeah. So I mean, we can stream. We should be able to stream right now the receive samples, or I mean the demodulated bits.
Yeah.
We haven't tested that yet, but if we want to we can put some more infrastructure in for streaming other diagnostic data from other parts of the demodulator.
Right. Yeah.
Currently, we don't have a way to even get those samples out, do we?
I think we do, don't we?
The IQ samples on the receiver?
Well, yeah, I mean, we can't say bypass the demodulator and put the IQs into the streaming. So we would have to update the FPGA, the design to like connect up various points that we might want to stream and multiplex those into the streaming bus, into the DMA bus.
Oh yeah. Okay. I see what you're
So
saying.
so I mean we just need a little bit of coordination on that so that if there's something we want to see, we can add it into the FPGA.
Okay.
Um,
Yeah.
yeah.
Well, I want to. I, I think we'll. I'd like to propose, at least giving a shot at streaming again to kind of see where we're at, and maybe we reveal some things that will help us figure out, um, because I could be the structure of the application code, the way that I set it up is not particularly sophisticated. So there could be something introduced by the way that the code is working, and I would really like to kind of back up and like go ahead. Let's see if we can adapt our current logic with all of the MSK in it to the streaming example that came directly from analog devices. Like let's try to hook that back up and see what we can do with it. And it may be limited. We might not be able to get a good view, um, but if what's coming out, if the receiver over the air is actually seeing the signal, then that's a huge step forward. So that was my proposal. After we for sure eliminated, leakage as being fault, giving us a false positive. No, so the RF loopback is really working, and that is it. That's like, I mean, that's a big deal. So the RF loopback on the same, back to the same radio working is wonderful. And it's like, okay, what's going on now that we are separating the two radios? There's got to be a explanation. So
I had a suggested test, which I don't know if there's any possibility that the reception is somehow dependent on the transmitter. Um, I mean, that would be odd, but I mean, it wouldn't be unheard of, and, just in terms of application code potentially doing something. So one thing that might be interesting is connect both Plutos together. So instead of doing a loop back on the first one, connect the first one to the second one, where the transmit on one Pluto to the receive on the other, and then the second Pluto we connect the transmit to the receive on the first, and see if you know if that might work, if data actually transmits in both ways. In the idea being there, if there was just some dependence on something in the transmitter, that's not running in the receive only Pluto
oh,
potentially.
right, right. Okay, yeah, I think we can probably do that. What do you think, Paul?
Yeah, that seems very feasible. We could try a full duplex test. Um, yeah, it would require a little bit of rearrangement of stuff, but nothing too difficult.
Yeah, not too
Yeah,
bad.
it's one of those things. It's a process of elimination sometimes, diagnosing these things, right? And running different experiments to see. But that's the problem with FPGAs. You don't have a lot of observability, so sometimes you have to you know theorize the problem and then test it and try to infer what might be happening when you don't have good observability.
That's right. Well said. Okay, well, we'll buckle down and do all this. We'll report it back on Slack and then reconvene in a week and tell you how it went, or tell everybody else how it went because you'll probably see it. Um, and yeah, I'm excited about this. It's we've added a lot to the code, and it's I'm optimistic. I think we can just keep at it. We will get it working. And I see that we have Daniel has joined us, and I'd like to say welcome to Daniel. And if you'd like to introduce yourself and say a little bit about where you're at and your interest in maybe open source FPGAs, that's mainly what we're talking about here. But anything else that might have drawn you to the meeting, please feel free to share.
Hey, yeah. Thanks for noticing me. So my interest here is gosh, I've been following what you guys at ORI have been doing for a long time. I've actually been in the Slack channel before and kind of like poked around and asked some questions. So let me just introduce myself because I think you'll be interested in who I am. So I I go by Dan, by the way, and I am like a SDR engineer, background. I spent about 10 years working at NASA and doing software-defined radio FPGA implementations. So I've got a strong background in DSP. And, part of the original interest at the time, back when I was still working there, was to look at, was there any possible way that we could provide some of the code that had been developed at NASA for a DVB-S2 chain to what you were doing. And so it was something that I had actually pursued through my boss and even through legal at the time, and found walls. And so it was something that kind of stopped me from sort of getting involved. I now, for the last, I left NASA in 2022, and, went and did some other things, but about, I don't know, about 9 months ago, I started working for AMD, the Xilinx side. And so, my role there is as the Milcom and Satcom system architect. And so, my job is to, number one, make sure that we're, meeting kind of customer needs, but, that we're building the right products for, the next generation of customer needs. And part of that is also developing things like reference designs for Milcom, Satcom customers. So that's now what I do in my day to day. And I've known about ORI and what you guys have been working on for a long time. I think I've downloaded was it Rattlegram, that app that I learned about through what you guys did. And I am an amateur radio guy myself, though I don't really get on the radio all that often anymore. So I just wanted to kind of come in and introduce myself. You may be wondering, like, why now? Why does he come in all of a sudden? And the answer to that is just kind of like, I've been at AMD now long enough where I think that I have a good understanding of kind of how things work internally. And I know enough people in the company that I could actually be sort of a valuable resource. And a lot of the things that I might look at are also related to what customers might do. Would be kind of interesting to see, what the experience is like for organizations that don't have as many resources, and improving accessibility to all of our tools and devices. So that said, I'm also very familiar with analog devices, integrated transceivers, and developed things for those in my time in industry as well. So yeah, any thoughts? I want to just kind of throw my hat out there and say that, if there's anything that you would, any frustrations that you might have with what you're doing on the FPGA side, I can be a resource. So
Wow, thank you so much. Yes, welcome. And it sounds like your rich background and your current situation and viewpoint. I think we have a lot to talk about for sure. And yeah, I look forward to discussing all sorts of things FPGA with you. And I only speaking not just for myself, but for everybody on all our teams. We're very heavily invested in AMD, Xilinx, and trying to get the most out of the hardware that we have, and to just make sure that people learn how to use it. So we have a educational mission, which, education in the sort of university sense, sure, formal education, but also personal and professional development, helping people further their career or to get the most out of it through open source applications centered around FPGAs. So we really appreciate you being here, and I think we'll have lots to talk about. And I'll let Matthew to have the floor to speak to what you've said, because I'm sure he has a lot of thoughts here.
Yeah, I mean, I think it'd be great having you join, and yeah, we'll all come and join this organization when we're ready. I mean, I've been also looking at it for a number of years before I was ready to join. Things just have to kind of be in the right spot. So I'm excited about what we're doing, and having more people with the expertise that you have, the better, because we all get to learn from each other and uh, and grow and improve our skills. So I'm really excited to have you on board as well.
Cool. Well, I'm glad to finally poke my head out here. So
Yeah, no, we're really happy that you're here. And yeah, thank you. I think I remember I might have spoken with you before about the DVB-S2 stuff. And
yeah,
the efforts
I
to
don't know if
kind
I
of get it kind of like liberated and stuff. And these are I'm not surprised by the walls and the roadblocks. There is resistance to publishing things. And some resistance is justified and some's not, and it's hard to kind of figure out which is which. So I just want to say we deeply appreciate any efforts to kind of like bring this stuff out to the things that shouldn't be siloed, the things that are not business differentiating or truly need to be held proprietary. All the rest needs to be out there, and it can be kind of scary. When you advocate for those sorts of things, you do find resistance and walls. And I just want to say, like, we really, really appreciate your efforts on that. It's that's the we agree with it, and we want to see it. And we understand that it can be kind of full of roadblocks and not work out. But the effort is very deeply appreciated.
yeah, and not to get too much into that specific issue, but um, you know, upon further examination, I originally was I can just sort of tell you what my experience was. I don't know if you've dealt with other people kind of at the government level, but most of the stuff that NASA was doing, and NASA is a great organization in a lot of ways, but one of the things that was definitely flawed was their approach to open source policy at the time, and contributing. In fact, they actually invented their own license over it, right? The NOSA, the NASA Open Source Agreement, which most open source advocates were like very against. Um, so uh, I don't honestly, I haven't really kind of followed it, but at the time I looked into what does it take to actually get something to go out with a better sort of license, and what are the options around that, and how to achieve it. So just in a general sense too, if you I think there may be other people that you know, look at things the same way that I do within government. And, in theory, at least from my viewpoint, I think that, government should be for the public domain. And so a lot more of their stuff should be open source in general, just in a broad way. Um, but, ultimately, um, so advocating for policy to that extent is a thing that would be helpful, right? I mean, like advocating for that sort of stuff, and creating pathways for employees to be able, government employees to be able to share that kind of stuff, would be really kind of advantageous to this kind of organization. So I don't know if that's something that you guys have ever gotten involved with. I mean, I know kind of a little bit about. There's all sorts of things that go on in the open source world related to policy, and I know ORI does that work too. But I don't know if they've ever specifically kind of broached issues around open source licensing of government produced works. So
We do have a little bit of activity here. Our main regulatory attention was towards ITAR and EAR to kind of like suss out to really fully specify the public domain carve-outs in ITAR and EAR, and successful there. So we did a lot of good work and to try to spread the word on that. Some other efforts that we've had to work more directly have been with like JPL, Caltech, and a series of meetings to try to like overcome any fear about going ahead and publishing work as open source with some mixed success. So some yes, some no. But it's the technical part's not really the hardest part here. It's the people part, and you just meet people where they are and try to convince them that yes, the government really should be in the on public service and public domain. This is an ongoing, like a iterative process. So, the things you've seen, I completely agree with that. You've summed it up very well. And we're active in those conversations wherever we possibly can be. Probably most often at the FCC, but also with various other parts of the government, Office of Engineering Technology and Wireless Bureau, talking about mainly amateur bands and open source access. So we'll keep it up, and we try to make a sort of a positive difference here, and try to understand that there's our concerns, and sometimes those concerns are warranted, but often they're just fear. So we try to break that down and show that there's a path forward that benefits everybody. So yeah, I think you understand the lay of the land here very well because you've lived it. And
Yeah, to a certain extent. Yeah. Yeah, actually one of the things that I'm kind of looking into now that I think you guys might actually be interested in too, truly kind of as a mainline technical goal for this year for me is to look at how we go into virtualized systems. And so I don't know if that's something that you guys have done much with or looked at ever, but obviously like the first kind of step of that, and I can speak a little bit about the history that I've learned now more recently about it, but basically the concept being that even if you look at the Intel acquisition of Altair going back to I don't know, it was 2015 or something like that. There was this concept of FPGAs going into the data center to do acceleration, and so that has kind of been a little bit of a failed experiment from the perspective of trying to get like software flows, really onto FPGAs in a way that's compelling. I would say, but interestingly, AMD did acquire, then Xilinx in 2022, with almost maybe kind of the thought that they could do the same sort of thing, perhaps.
right, yeah,
And there were some efforts into that on the data center side, but I will say that, the way that has kind of bore out is that most of the customers that are using, for example, the data center, PCIe based cards, they're writing, their own RTL code for that, right? So, the software flow has still not really been a winner in that avenue, even though acceleration as a whole, has shown promise, right? So, and a big name of the game for me, right, professionally is how to make customers unlock the power of devices, right? So I think open source is a great way to get that out into the open. I do, when we publish reference designs, those can be kind of good examples too, but we don't, I guess, those aren't always even open sourced. And so, having examples of that in the open source domain can be really valuable. And so one of the things I guess I wanted to ask is, if you guys have looked at, virtualization kind of stuff, because that's one of the things that I'm going to be sort of looking into this year is not just virtualization at a software or hardware processor traditional CPU level, but extending virtualization out into co-resident FPGA fabric that's in a system. And what are the actual virtualization mechanisms for doing something like that? And that's, I think, something that could be kind of powerful going forward. Still with the ear towards not really software based, but still allowing for that virtualization, right? And to some extent, cloud providers have sort of done this sort of thing. They've rolled their own, and each one does it sort of differently, where they manage access to then some FPGA fabric that you might want to load up and run when you're doing stuff in the cloud. But for any other user that might want to do that, or even have something virtualized that runs on an SoC that includes ARM cores, co-resident with FPGA fabric, and just virtualizing across the CPU to FPGA PL domain. There's not really a lot of stuff out there for that. So I don't know if that's something that you guys would be kind of interested in looking at either, or if you have ever looked at it before, but it's actually going to be an area of learning for me that I don't know a lot about. So,
Okay.
Hey, Daniel.
Oh, go ahead.
Hi, this is Aaron. And I just welcome. First of all, thanks for being here. I just wanted some of the things that you were saying about being able to utilize FPGA fabric. So I work on an open source project called OpenCPI, which stands for Open Component Portability Infrastructure. And that's one of the things that we try to do, which is enable hardware.
Piece of it.
Well, it's not necessarily, it's enabling hardware acceleration from CPU, but provide the infrastructure for you to focus on doing the hardware acceleration piece that you want to do, and have a uniform way of programming both the software and the hardware side. And we do support PCI Express as an interface as well. So if you wanted to put an FPGA that has PCI Express on your computer, you can then utilize that for if you're just doing hardware acceleration. So I just wanted to throw that out there, that this is like a tool that is open source and kind of allows you to do program your application to utilize and the FPGA fabric. But yeah, as far as the virtualization piece of it, that's something that I guess is at the application level. But that'd be something to look into as well, to maybe where can OpenCPI fit in that space.
Okay. Yeah. I think of virtualization at certainly it's enabled by hardware, but at the the kind of the operating system level, right?
Mm-hmm.
So it provides things within the kernel to basically facilitate access to resources. So and there's drivers with high priority processes that can process that. And so I guess that's the way I'm thinking about it today.
Okay.
But it would be interesting to see how OpenCPI would fit into that. And if I'm sure there's useful things there. But how far does it take it, right? And is there more that can be done? Is that within scope of what OpenCPI is trying to do, or would it be something that would make sense to layer on top of it?
Yeah.
Sounds like there's plenty to talk about.
Yeah.
Very good. Yeah, no, if Aaron and Daniel, like if you, or Dan, if you don't already know each other's contact information, then if you put it in chat or email me or email our main list if you're both on our the ORI's main email list and we'll
Yeah,
try to get in
I'll
touch.
I'll I'll just drop my email in the chat here.
Yeah. I think then
Daniel, I saw you on Slack. Do you participate much on Slack? That's a nice way to get in contact as well.
Yeah, yeah. Honestly, that's a good way to do it too. If you if you tag me, then it makes sure I see it, which is really the key thing. If you have anything for me, but yeah, I don't I generally speaking have right in the past obviously haven't really been all that involved, so I haven't really been on it all that much, but yeah, that would be it's a platform that I'm on
oh, okay.
regularly. So
I mean, yeah, anytime I mean, we're posting there a lot, especially about the MSK modem. Any comments, thoughts, any way that you want to participate, yeah, feel free to make comments or post there, and that's most welcome.
okay. Yeah, and by the way, before I logged on today, I mean, I did go to the GitHub and check out like activity on recent projects and so I was just kind of like, okay, well, what is really active these days? Obviously, there's a there's been a lot of stuff going on for a long time, so a lot of this stuff goes back a little bit further, but um, if as sort of a level set, what would you say are the most actively being developed projects or priorities right now?
Well, that's a good question. I think that we're focusing on the uplink because it's a sort of this is a new digital protocol using minimum shift keying. So it's opulent voice, which is a uplink for the space project, and um, that part was the least developed part, so it needed some attention. And so recently, that's we've been bringing it kind of up to snuff. The downlink is in decent shape, still needs some work. We have a to-do list on the DVB-S2 pipe downlink. And then the sort of the quality of service based multiplexing on the payload is theory, really. We think we understand the rules and we've got state machine proposal at least sort of running in Simulink, and we've got sort of so now that's falling behind as the least developed part. So the way that we tend to do things is we attack the thing that needs the most work, or and then whatever is it's open source project, so it's all volunteer. Whatever seems to be the part that brings the most joy to the most people to learn the most and to really kind of achieve high quality results that's attractive in and of itself. So right now the uplink is getting a lot of attention, and then the uplink receiver has gotten some attention because it's another based on another open source project. We took the Theseus cores base and then customized that for the uplink receiver. So it's a multi-rate receiver. It's really, really kind of nice. A really kind of wonderful little bit of code. Some trouble there in just getting the FPGA development station to cooperate. So we tried no OS, we tried Pedal Linux, we've tried now Yocto, a more pure Yocto build because of the warning about not using Pedal Linux for prototyping or production. And lots of difficulties just kind of getting it to function from a sort of a lab level. But getting the math to work and getting the HDL to kind of shine, that part's done okay. So I think that probably answers a little bit of your question on what the feedback that we can give you is some of the fit and finish of getting things to work in the lab, at least for an organization of our size and type. Being very distributed, international volunteer team, the documentation sometimes is good and sometimes is not, and getting things to work and being able to find out a workflow has been surprisingly difficult. So probably the hardest part from my perspective is getting it to, figuring out how to boss this stuff around in the lab. Integrating the IP or IP into the reference design was not straightforward, and getting technical support was not straightforward. Getting answers from the engineer zone, not straightforward. So it took a lot of persistence and consistency to get any sort of answer that was applicable to just getting IP to work in the reference design. So that's kind of it's a very short, compressed sort of bit of feedback on where we see the challenges, and that's because we have to do everything ourselves.
Sure. Have you guys had a line directly into the Xilinx organization before, or
We've
would I
been
be the first?
we're told to just go to engineer zone and ask. I did have a decent conversation with customer support about a missing web page on how to integrate the IP into, get your IP into into the reference design. And the reason that I needed this web page is because it was missing. And, it turns out that in the transfer to or from github.io, it got lost. So a little bit of information there on how to make the TECL scripts work was missing. And, through the process of asking for technical support from it was eventually delivered, but it was difficult. So I don't know. It's hard, but we're prepared for hard. SDRs, hardware design, embedded Linux systems, lots of moving parts, multiple companies involved. Of course, it's difficult. We're prepared for difficult, and we can plow through it and work on it and get results. But no, we haven't had any ins or uh, any special treatment or anything like that from any of these companies.
Yeah, well, as a long time, Xilinx customer before I started working for them, obviously I've had my share of frustration with tools and documentation, and so my hope is that being with the organization now, I can help to alleviate those concerns, especially for those in the open source community. So, I'm not gonna tell you that I can deliver the moon or the stars, but I can certainly try to help grease the skids here and find ways to help out, or if I know of ways to do things, even myself. Most of the one of the things that's kind of hard and that as an organization is challenging is sometimes when you make the products you aren't always the best at seeing how easy they are to use, and so it's I have a little bit more appreciation. There is a ton of complexity behind all of the devices and tools, and a lot of things that the organization has to support. And so, generally speaking, despite my former experience, where you might wonder like how could they possibly have ever let something like this happen, there are usually good reasons as to why things might not work the way you expect them to, and it's because it's kind of hard to support other products. So hopefully I'm a halfway point between being a sometimes frustrated user and somebody who drinks the Kool-Aid and is siloed from the user base, if that makes sense.
No, totally. Makes absolute sense. Open source projects are guilty, very much so, of, you know, nerd speak, I guess it's the term. Assuming that your audience just knows all these rules, that they just get it, they just kind of know, not having good documentation, making lots of assumptions. So this is a broad problem in tech and not limited to any particular one.
Yeah. Hmm.
So,
Hmm.
we we're we try very hard to not do this ourselves, but it's an incredibly difficult thing to avoid. I think it's a human nature tech thing and all. So I'm just thrilled. Thank you so much for reaching out and being here and being on Slack and noticing what we're doing, and we're so very happy to talk with you. I think we'll have lots of good conversations moving forward. And what I'd like to do is try to be of great service to you, to try to give you really quality feedback and to, in a sort of efficient manner, to kind of let you know
Hmm.
questions that you have and you want to essentially interview us about our experiences. I think that you'd find a lot of people very willing to provide that feedback, so that that you have everything that you need in order to make progress. Because I think we all would really like all this stuff to work better. There's just so much great potential for software defined radio and for this hardware, and I mean it's a golden age. So in making it easier, I think we're all very deeply committed to that. So please count us in, and I'm looking forward to talking with you more. Cool. Let's see. I do have some things to share. I know we're coming up on an hour here. So I have a slide deck of stuff from ITA still, but I'm gonna open the floor back up because we talked about a lot of really interesting things there. So if anybody has any comments or questions for Dan.
I just want to say again, welcome aboard, and I think I hope you find what we're doing interesting, and look forward to working with you on some of these projects.